Thank you on that. Recording now. So in our get choice, we asked them for a choice, but we didn't really do anything to validate it or to check it or confirm it. And if they gave us anything bad, we would either crash or just move on with it. Now this time though, what I want to do is kind of add in at least a little bit of debugging. We know we need to ask the user one time for their query. And we just need to validate whether or not it's between the min and max. So how can we keep asking the user until they give us a number that is in between the min and max? We need to repeatedly do something until we get something right. What can we use for that? How can we handle that?
Use an if statement.
If statement will definitely check to see if we got it, but will that repeat it? If not, will the if statement allow us to repeat the item if they go outside the min max? How will if statements repeat the code? If we can make an if statement work in the game, I'm just asking. I'm going to ask whatever the question was. Not picking on saying that you're wrong or technically wrong. What I'm just saying, this is what we need to do. So if you realize it can't be done, feel free to just say, like, oh no, yeah, if statement can't repeat, or if it can be like, we can repeat like this.
So going off of what Gabe said back when we were first doing Yahtzee and was talking about his console and everything, I remember him saying he used a while true loop to have everything repeat until you get the answer that you wanted. And then inside you just nest an if statement that if it's the requirements are met, then end the loop. But otherwise,
no, that's actually, and so if you're dealing with a loop that you know you need to break out, but you're not sure exactly how the conditional is, you can do a while true to make sure that it runs until you decide how to break it. If you're not sure how the logic's going to break it, or if the logic is too complicated to do in a single condition. There's multiple ways to exit out, and that could be it too. In this case, for example, we could do while true, query, just like put the curly brackets. We'll do the close. So we need scanner, by the way. How about that? Next int. If value is greater than min, we'll do inclusive, greater than or equal to min, and value is less than or equal to max. Yeah. We'll then do what? How do we, if this is the case, we have the value is greater than and or equal to min and less than or equal to max. In between those two. Yeah, if our min is 1 and our max is 10, if we got the number 0, well, it's not greater than or equal to min, so that already kills it. If our answer is 1, well, it is greater than or equal to min, and it is less than or equal to max. That works. If our number is 10, it is greater than or equal to 1, and it is less than or equal to 10. If our number is 11, it may, yes, be true that it is greater than or equal to min, but it is not less than or equal to max. So this line here on line 12, we got a number that is valid. It is greater than min, but less than max. So what is the command we use to get out of the loop?
Is it break?
That it is, yep. Very good, break. That'll break us out of the loop. So this is the item we can use. Now, what I'm gonna point out is we have a single condition that allows us to break out. So we do have a single condition. We don't wanna put that here because that will cause us to have a slight issue where we would have to event. Here, I'll show you on the transit. Here we go. I'll show you what the problem is. So to do this here, the problem with that is value is scoped inside of our loop, right? So we can't test loop and value is here. So what we'd have to do is we would have to move this, not that, this, copy, int, outside the while. Problem is, what's going to say here is that we have not initialized the value in order to test it. We can't test an uninitialized value, so we have to give it something. The problem is there something we can give without breaking the system? We need this to run once, but we have to give it a number, but any number we give will be evaluated against this right away, right? Is there something else we can do, or do we have to do the while true system? Or is there another thing we can do?
You could subtract 1 from min or add. So like, oh, wait a minute. Yeah, because then it'll be tested against that. So if it fails, won't it run the loop? Oh no, that only runs if it meets the requirements. Okay, never mind.
Which I will say, yeah, we do have to switch this. This right now is saying while we have what we want, keep repeating. So we would have to switch it to the negative, while our value is either less than our min or greater than our max. Keep asking until we get a number in between. So we do have to do that. We would have to change it. So good check there. That is one thing we'd have to change on this. But again, the main thing I'm going to get to is that we technically want this code to run once before we do the check, right? Now, yes, I could set value to min to start, but then that's kind of like not right. Because then we're saying that the value is min. What if the user doesn't enter an integer? We don't know what value we'll have. If the user enters something that's not an int, well, we know what next int does, just keeps asking and doesn't tell them an error. So we're probably going to switch this to next line anyway, but getting a little ahead of ourselves. We want to have the code do something until something is true, or while something is true. What type of looping structures do we have? What are the loop structures we have? When we have this while loop, what are some of the others?
For and loop.
For and loop, we have that one. That one's unique to Java. Yep. Any other loops?
For each.
The for each, that's the method, the for each method, which is a looping system. Yep. What else do we have? I'll give this one. We have the standard for loop that you guys like. Let's do one more. Anybody remember it?
Is it for of?
No, that one doesn't sound familiar. No, I don't know that one. For of. No. Do you remember the do while loop? Remember that one? The do while. The do while has a special behavior that the while loop doesn't have. As I'm trying to explain here, the while loop has an ability to you could accidentally trigger a false positive on the first check. If I set this to 0 and our min is 0, then we don't even run it. And we always take the 0. We never run this code. So there's a potential to accidentally code in a logic error on this item with the while loop. There's no guarantee that this code is going to run one time. A do while, on the other hand, guarantees the code will run once by doing do and then grabbing that, and moving that here. What that does is tells it, hey, you know what? Run this code once, then test to see what the situation is. And if it's not true, if it's true, then run again. So saying do this code here while our value is less than our min or greater than our max. Well, it's not the number we want. Once the number is within the range we want, go ahead and break out. You're good. Do you see how that works? The only other thing you might want to do in this, and I'm not going to do it because I'm going to just take the way the next int works, but if you want to give an error if the user doesn't enter an integer, you could always make sure you take the next line. You can do next line, do a parse, and if the parse doesn't work, go ahead and give them an error message and repeat and set value to something outside of the range. So min -1, as I think Christian mentioned. You could do it to min -1, and that way it's outside of the range. You could also run, actually, that's something I would have to check, to continue inside the do while loop. Would that cause it to just jump back to the top and not run the condition? I'll have to test that off camera on another time, but that's something to think about. Does the continue force it here, or does the continue force it here and not run the conditional? So does continue force it to keep going, or does continue jump to the bottom, which then causes the while to trigger? That's something I'm actually not clear on what Java does, but not important for this situation. Once we have our value, we're just going to go ahead and return it. That'll do the get int. That will do a 1 and 4 on what number. It'll print the number and do that. Let's make sure that works by just running this in our main class. So head over to main. We'll remove our code here because we don't really need it. So we're just going to test our console. So I'm just going to do console. Not allowed. There we go. Not. I don't think I made it static, so I got to instantiate, I think. Hold on. Console equals new. So I'll make it static later. It's fine. Console dot get int. We'll do a number between 1 and 10. And number. No. There we go. Let's just see if this works. We'll run it. So if we give it a 0, give me a number. If I give it 11. Give that. Nope. If I give it 4 though, we are happy. See how that works? You can see how it asks right away. Let's take a look at the console again so you can see how it works. Now it makes sense. Like we said, we come in, we set the value to 0, which is perfectly fine. We do the do while, which prints out the query we sent. So we can ask whatever question we want. That's what's nice about this. This method is very dynamic. We can ask whatever question we want. So we can use this method for both the getting the value of the dice as well as how many dice we want. So we could say, now to actually showcase what we want this time, let's go back to main, change this now to 1 to 6. Die value. Change this to int value. Equals console.getInt. Min, we'll say again 1 with a max of, as we said before, 14. There's going to be a max of 14 dice. How many? Work. Even though the S might be excess when we only do 1, but it's fine. It might read a little off. Die value. here. How many dice? How many 3 dice? There's 3 of them. There's 4 of them. We claim 4 3s. Seems like what we want in our game, right? I'm going to change it a little bit though. Say die value 1-6, just so I know what they want. And right here, how many dice? 1-14. Just so it knows what I want. So we'll end up using these later on. So I can keep these, but we're not going to yet. This shows us that our console.getInt method will actually do what we want. Let's add one more. Boolean. Get n. Get yes, no. No, I'm going to say string query again. And ask a question. We'll do a do. And so we do. Sorry. This I'm going to do string input. We'll do another do. We do s out. Query. And this time I'm just going to accept the item. And this time we can. This is where you guys could have a little more friendliness in it, a little more playfulness in it, or a little more deciding factor. You say, well, we'll look at the yes, we'll take yes, y and n, yes, no, tf, true, false, whatever, however you want to do it. You can even offer in here, we can even say, you know what, do string yes and string no as a way of saying, well, which one's yes, which one's no, right? What values are allowed. And so then you would confirm whether or not the value is one of these. And if it's at least one of those, then you can continue on as long as it's one of those. So we can do input equals scanner dot next line while input not equal yes. Oh, sorry, compare equals yes. It does not equal this, and it does not equal or no. You see how that works? That if it's not equal to either one of these, if it's equal to one of them, we're okay. We want to break out. But as long as whatever they input is not equal to one of our 2 options, the yes or the no option, we're going to exit out. That makes sense? How that works? As long as it's equal to one of these, we're happy. If it's not equal to one of these, we want to exit out. We want to keep doing the loop until they give us one of those 2 items. That's not least, we're going to return a nice, you can use a nice ternary expression. It just says input dot equals yes. I'm not even ternary, just that. Because if it equals yes, then it's true. We want true. If it doesn't equal yes, then we're false and we're expecting it to be no. We can assume no. I don't have to test if it equals no because this system already did that. This system already is going to tell me that the input is going to be yes or no, right? And so because of that logic, I can do this and be able to handle both situations. If it is equal to yes, then I got the yes answer. And then I want to return yes or true. If it's not equal to yes, then this is going to be false, and that means I want to return false anyway, right? Any questions? Does this make sense? If it doesn't make sense, please ask. There's a line of code here that doesn't make sense, definitely ask for it. As the logic is following, very good. Let's see if this works. Back to my main class, we're going to comment these out for a second. Boolean result equals get yes no. We'll say y n Player lie. ILM. That. And we just do again, S out, result. Play, not that. Play again. Did the player lie? I'm going to say, I don't know. Asks me again. I'll put the yes, we get true. If I run it again, put capital N, I get false. So the downside of this, of course, is that our system isn't automatically going to capitalize the result. So the downside here is that if I do the small y, it doesn't accept that. So that this is very basic. What's it going for? What I've done here is a very basic system for determination. I'm not really checking for any sort of like case sensitivity. I'm not worrying about case sensitivity. I'm enforcing case sensitivity. So that's something to keep in mind. This is doing some very basic stuff. It's fine for an MVP. Definitely something you can point out in an interview like, hey, this is something that I would probably tweak up a bit more, but this will work for the time being. It has some minor validation in there, very simple validation, but enough to get the job done, right? Make sense? There it goes. Ends. Awesome. So that's our console class that will allow us to actually get input from the user. So we go back to our player class now, which is what we needed this for. We needed to make claim, get from the user items, and decide if we call or place. So let's make a claim. Public. We'll do void for now because I don't know what we're going to return yet. We don't know what we're returning. We'll probably return 2 ints, but for now we'll call it void. What was that? That was only 2 students trying to get in. Let's make turn. That's nice. Good news there. Anyway, so public void get claim. And like I said before, I've said this before and I'll say it again. In the beginning, if you don't know what you're returning, you don't know what the goal is, you don't necessarily have to know what this is going to be in order to start writing your code. Start void until you know what you need, until you know what you're going to send back, and then put the variable there. No one's forcing you to have to understand your code right from the get-go. All right? Don't panic, be like, oh, I need to decide the return type this very minute. Not at all. Once you know what you're going to return, once you know what you're going to use from it, that's fine. All we know right now is what we need to do right now is just ask the player the dice and the count. So I'm going to do 2 ints, value, int count. That to a comma. There we go. So 2 variables. Let's go ahead and get them by doing, also do console. Console. Console here. So let's go ahead and do what we need to do. So we know that our die value and our die count are going to handle validation. We know that our get int is going to handle the validation. So no need for looping here. The actual method will take care of it. So all I need to do here is do die value equals console.getInt. For the value, we want a min of 1 and a max of 6. And our query is going to be simply what? -6. And our die count. Honestly, I probably could just copy that from the main class. We did already kind of code this or type this out. So save a little time. We'll grab that. Oops. This is replace with die value. So this will get the two numbers we want. And is that enough? We get the claim from them and then we're done, right? Anything else we need to do? Look at our plan of attack, which I did not open. Oopsie. Last plan of attack. Over. We take a look at our player class. We got get claim, get decision, validate claim is out, name cup. Anything in here we need to take? We're concerned about. What do you think? Or we think our get claim is done. Got that. We got that. We're trying. We typed up get claim. Is there anything else we need to do with get claim? Or are we good?
Can we go back to the player?
One more time.
Can we go back to the player?
Sure.
Okay. Okay.
So get claim. Have we gotten the claim? With these two items here, have we gotten the claim? This is just yes or no. Take a guess. Do we have the claim once we get these two values?
Yeah.
Yeah, right? The only thing that somebody might be, if any of you are thinking, well, do we validate now? Well, does get claim validate? Or is get claim about getting the claim? Validate can come later. Validate can be, you can validate the claim after you get it, and that way you can use the loop on this method if the validate comes back false. Validate claim would be a nice Boolean method. So could you do validate here? Yes, you could validate the claim here. Then you would have to encompass this stuff into a do while loop inside of the get claim. And now we're doing multiple things inside the get claim. Get claim doesn't say anything about getting a valid claim. If you want to do that, you would call this get valid claim. And then that would include not just getting the claim, but also validating it as well. This method is called get claim. That's all it should do. This is that idea of code simplicity and clean code. That's what I want to mention here. If any of you did your validation in here, I would not really dock any points for you. I might dock 1 point just because it is doing a little too much. Overall, I wouldn't. This is where we get into that concept of keeping code small, compact, and doing one thing at a time. This method's sole purpose is simply to get the claim from the user. It doesn't mention anything about whether or not we're confirming that the claim is valid, confirming that the claim is okay, or doing anything with the claim. All it needs to do is say to the user, hey, what is your claim? What dice do you want to claim, and how many of those dice exist? Right? That's all this one needs to worry about. The validate claim method can handle validating whether or not it's a okay claim because it also needs additional information. It's going to need to know what the previous claim was, if there was a previous claim, right? We know that there's more difficulty there in the validate claim. And it's also possible that maybe the player isn't the one to validate the claim, technically. It's not the player that decides whether or not their claim is valid, is it? The rules for whether or not of a claim come from where? Where do the rules for a claim come from?
The game class.
Yeah, the game decides what a valid claim is, right? When me and Christian played our game, I changed the rules to how claims can be made, right? I said that if we have to increase one or the other, but and that's it. That was the rule. From the actual game, yeah, you have to increase one of the numbers, but if you increase the value, the die value, you can set whatever count you want. So with the game me and Christian played, we actually had a different claim rule than the actual game does. So the player doesn't really decide whether or not their claim is valid, what rules they're applying that time. The game decides whether or not their claim is right. So notice how we put them here and here. So we're actually going to remove the validate claim from player. This has made it more clear now. Now that we've worked through this, we're starting to code it and realize, you know what? Yeah, it doesn't make sense to have validate claim in the player. The game decides it, and that way, if the game, if we want different claim rules, we would change it in the game, not in the player. So remove it from them. They no longer worry about that. So our get claim method is done. All good there. What we might want to do is either maybe we might want to return this or maybe set these as a value to the player class. The player's current claim. So there's two ways we can do this. We can set it as a field. We can also return this information. We have two integers to return. That can make it difficult. How can we return two integers? If we wanted to do that, just for the thought experiment. If we wanted to return the two numbers, how would we do that?
You could
just store them into like a list or an array?
That's an option, right? We could store them as a list and array. In this case, we probably could get away with an array because we know it's only going to be two numbers, and that we can save some space. But a list also works too, because then we can still set two numbers. Any other ideas? I think I heard Christian talking.
I was gonna say that.
You gonna say the same thing? Any other ideas? Does that sound, that makes sense? Sound good? Yeah, no, you can't, just to clarify, no, you can't send back more than one value, more than one item. You can't do like, oh, it's gonna return int, that doesn't work. Or int. You can't send back two items. If you want to send back more than one thing, it has to be in some sort of collection. So go ahead.
Could you send back a string where the numbers are just spaced, where it's like
Could do that.
first number could do value
Yeah,
and
could do
count
that.
or count and value.
Yeah, definitely could do that, and you could also separate them with a space. So that is one way you could do it.
That's what.
Yep.
Yeah.
That way you can do the split on the space. So that's another way around it. So there you go. We do have another method. We can send it back as an array or a list. We could also send it back as a string with a space in it. So then we just split on the space and get our two numbers. At the same time, like I said, we could also add them as fields to the player and access them that way. I actually like the personally, I think the idea of the array sounds nice. It's simple, it's easy. So we'll do an int array. Return. And int. We can just do that one with the value. Yep, that is cool. That makes that look good. Only way it's something that if someone wanted to argue against this is someone said, if let's say the interview they did ask why might you want to not use the array? Can someone come up with a reason why you might not want to use an array? Yes, this is a tricky one. Like that's why it's an interview question.
I mean, the only reason why I can think of is that you have to re-access the data and figure it out again. I mean, because technically, if they do like, 4 ones and the next person, or they go to their claim again, it's 5 ones or something, like instead of altering, like you don't have to change the value, you just have to change the amounts. So it's kind of like you're changing data more than once that you don't need to, or
that's one way to look at it. Definitely, we're kind of recreating arrays or overwriting the original one. That could be an interesting argument. For me, since it's an interview question, not really an actual like programming question, there's nothing wrong with it in the sense of memory, in the sense of performance. What the problem is going to be is readability. when you're accessing these items, you're accessing die value via 0 and die count via 1. And so 0 doesn't really mean die value, right? The index 0 isn't as legible as the word die value. And so somebody might argue, say, you know what, you should probably use a dictionary just so that you get that key value pair. So there's that identifier so that you know what this item is, you know what that item is. So that could be that's an argument you might get, that instead of doing an int array or a list, maybe do a dictionary so you keep the key value pair, that identifier in there. That's the argument you might get from somebody. So always be aware of that, be prepared that you might get that in an interview question, but that's about readability. That actually has less performance. Using the dictionary over the array would have less performance. So you can gladly point that out. No one would ever get mad at you for using this, but that would be if you had an evil interviewer who asked you, what's one reason you might not want to use an array there? Readability. That would be it. Just to showcase it, you can see what I mean. Let's head back here to test our player class for a second. Don't need any of this anymore. Player.getClaim. One. Out. 0. That's out. 1. Note how I did 1, 1, but there's no real, I can't really tell which one's which. I'm accessing each end via 0 and 1, not via any sort of text. So again, what is 0, what is 1? In order for me to know which one's which, I now have to go into the player class to confirm what is 0, what is 1. I have to go to another file in order to verify. If I'm someone coming into this code that's never worked on it before, if I'm a new developer coming into this, in order for me to know what 0 is and what 1 is, I have to open the player. I just closed it. I have to open the player's class, find the getClaim method, and take a look as to what it is. It's not so easily noticeable. I have to go do extra research if I want to know what's going on. Does that make sense? See how that works? All right. So that's the only argument you might get for using an array versus something else, and even using an object, a claim object, a very basic object. So, and that's where and I'm not going to get too deep into it, but that's where you get into the argument of, well, when do you use a dictionary versus creating another object? Do I really need a claim object? That seems excessive. That's where you're like, this is just storing two ints, use a dictionary. That's getting a little too deep into it, so I'm not going to worry about that. All right, we got our claim, die value, die count. We also need to get from the user if they're going to call the liar or play. So in here, we're going to go ahead and do public. And this time, we're just going to send it back to Boolean. We'll do void again, actually. Let's do void. Decision. All we're going to do here is do Boolean. Called the lie. Do that. Yeah. Boolean called lie equals console, which I'll probably actually put that up here. How do you think about it? I'm going to use it in two places. Yes, no. Okay. And actually, we're not going to do capitals. Capital, player, play.
So you're returning true if it's a yes, false if it's a no.
Yep.
Right.
Yeah, that works for me. Do you call the previous claim? Liar or yeah. Then again, we can also just switch to the yes or no, however you want to do it. I'm going to do liar or play right now. That's fine. I may even actually just do it like this. This is an interest. This is how you can showcase using a single letter So if you do that, that usually hints at doing this or this. When you surround a certain character with parentheses, it usually tells the person you just need that letter. That's it. That. In this case, again, is this something we can return? I think it's just a returnable item, right? We don't need to validate anything. We'll let the game decide what they do with the decision, right? What are we returning? Let's do a sanity check. Let's see who's paying attention.
Boolean.
All right. Yeah, the only thing we have here is a Boolean. So, and really, we don't have to really save it as a variable, do it. We can just return the result, right? So we know that this is going to do the validation. It's going to get us what we want. It's going to give us our true or false. So we can just return that straight back. And now, again, we have that. So if we go back to our item here, there's our get decision. Who is out? So now we decide as the player if the player is out of the game. Let's find out. How do we know if the player's out of the game or not? What decides the player's out of the game? In Myers Dice. What was the rule? Does anyone remember?
Is it if you run out of dice or you have 2 or less dice or something like that?
Which one was it? Christian, what's the official one? You're muted.
What was it? What'd you ask?
For Liar's Dice, when are you out? 2 or less, 1 die, or no die?
We play to no die.
No die. What do we want to do, people? We have 3 options: 2 dice or less, 1 die, or no die. When are you out? Last vote. This is our program, so.
No dice.
Go the whole way. Let's go all in. In is out. It's going to simply do return cup dot. We have how do we count the number of dice? Do we have a way of counting the number of dice? Let's go take a look at our cup class. Let's see. Is there a way to know how many dice we have? Do we have that here? Any way to know how many dice are left in the cup?
The length of the dice list.
We can get the length of this, but it's private, so we don't have access to dice, so we don't have a method that lets us know, right? So we're going to do something called a pass-through. Public int size. We know that since dice is a list, its method for this, for its length is size. We use the same method name, and all we're going to do is return dice.size. And this is why I'm calling it a pass-through. We're passing the size method from dice into our cup class. We're not running size on anything else. We're just taking that method from dice and making just that method from the dice class public. No other method from the dice class is being made public. The dice field itself is still private. Only method from the list we've made available outside the class is the size method. That's what we're doing here. We're taking that size method and making it public. But the rest of it is still private. We're still keeping the whole thing private. So cup dot size. Out is less than or equal to 0. If they somehow get less than 0 dice, they're out too. But as long as they have 0, once they hit 0 dice or less, they are out of the game. So that means yes, they are out. Once they hit 0 dice. Looking good so far? Go back to our plan of attack. Let's check. Look at that. Our player class is done. Look at this code again. Let's take a look at the code and make sure it makes sense. Yeah, let's take a look at it. Let's make sure it makes sense. So our player class, we have the static value of dice number, which just says how many dice they get when they start. They have their cup, which is the cup class. We have a name for them, and we create a console so we can ask them questions. We set the name, and we create the cup. We have a shape cup that is, again, that pass-through that just rolls the cup. It just tells the cup to roll the dice. We have our peek pass through, which just allows us to peek at the dice in the cup. We have our make claim. Well, let's get the claim from the user, which gets the two values and returns it as an array so that the game can decide what to do with it. The game can either say, yep, this is the first claim, so just accept it as is. I don't care what it is. Or, yep, this is not the first claim, so let me make sure this is a claim that they are allowed to make. This is a valid claim. Next up, we can decide if the player can either call that as a bad game, as a liar or not a liar, yes or no. And then we can determine, did the player drop out of the game? Let's test each of these. Let's go back to our main class now and test them to kind of make it look like we're kind of playing the game. So in main, we created a player.
Wait, can we go back to player one?
Oh, sorry. Of course. You're looking at it. Does anyone else have any questions of any line of code? Any of this code look off? That makes sense. Any questions about why we did it in the same way or why we have certain code? Please don't hesitate to ask questions.
Okay.
All good?
Yeah, I'm good.
Cool. So our main class, we're just gonna, like I said, just gonna test them out. So with the player class, we know we need to do player.roll to start the game. So I'm gonna roll the die once. We will peek at the dice. We'll then do player.claim. We'll save that int array claim equals that. Oops. We'll then print out, just for the fun of it, player claimed there are and what we'll do here is we'll just do a simple if. Actually, I got an idea. That's out. Decision. Called. Play for a second. Let's see what we get. See what happens. So we get our dice. We're gonna say, you know what? We'll go ahead and say there are 3 threes. So 3 threes. I don't know why I printed that twice. That's strange. It's fine. You call, oh, they probably hit the enter twice or something like that. Anyway. Do you call a previous claim? Well, let's say it's a liar. So it says, well, I called. That looks good. But again, this time we'll play. So we got 3, let's see, we'll say, so die, we have 3 ones, so we'll say that. One dice, there's 3 of them. Still printing it twice, which is weird. We'll play. We'll have to check that out later. It's not an actual, like, any sort of bug that's really affecting us, so we'll have to check it out later, but we do have a small bug that seems to be happening there, where it's printing out the get position twice. All good, though. So far, so good, right? We kind of mimic the game. It's me playing by myself, but I am kind of playing the game by kind of mimicking it. So I'm saying, there's my dice, I'm making a claim, and then we're acting as if this is being printed out to the second player now. The second player says, okay, the player claim is this. Do we call them, my play? And do you call the previous claim? And we're saying, no, like either call it or I. I either call it or I keep going. Hopefully it's going for a second. All right. There's our player class. Any questions on that? Or does that seem good so far? We have one last class to build, and that's our game class. It's going to store the players. We will probably remove the validate claim elsewhere. We'll run the turn. I'll probably move this one first. We'll start to build that. We'll build out the run turn. We also probably need to do we have the construction. Run turn is liar, check dice to see if they are a liar. We check to see if there is a winner. Is there only one player left? We need to remove the player if they are out, add a player, if we bring a player in, and run the round. So that run turn, run the round. Remember, there were two options. The turn is that idea of what the player is doing. It's the player's turn, which is to either make a claim or decide whether or not they're lying or to make a claim of their own. So that's a turn. The round is each time we roll the dice. So we roll the dice to start the round, and at the end of the round, we then decide who lied, someone loses the dice and roll again. So that's where the two things are. We have run turn and run round. Run round seems to be that higher level item. Run turn seems to be the smaller item. Let's start the class and get to a certain point where I feel like we're good enough to stop for the night. Let's do 50 liars dice class now. This is liar's dice inside of liar's dice, which is fine. If we look back at our plan of attack, we need our players. So let's at least create that. I don't want to store the players.
In a list.
We can do a list. That makes sense. Yeah, let's do that. Players. Why did I not bring that in?
Remove the player before the list.
You're right. I don't know why I did that. That should be public. Now if I do it, it should bring it in. Let's sketch. There we go. Didn't register because it's a P word. All right, so public list players. So now we need to do the constructor, which is we decided to play the game. We're going to play liar's dice, so let's construct our game. Let's build it up. So public liar's dice. And so if we're going to start the game, what do we need? In order to play liar's dice, when we set up our game, what do we need?
Players.
Yeah, we need to set up the players. So first, we'll start first with players. Equals new list. That was weird. Just gonna do that. It's fine. Usually. Oh, it's not being done. That's why. List. There we go. And now we have the players collection. Now we need to actually add the players. And one thing we can do is actually over here do a int num players. How many players are we going to bring in? So we can do for count 0 less than num players. Yeah. Plus, and now we're going to actually do players.add new player. But we need a name. How are we going to get the name?
Using one of our console
Yeah, we're using console, right?
methods. Yeah.
Let's take a look at our console though. Do we have a way of getting a name? No, we probably need a get string method, right? do again in query. This one should have no validation required. So we simply should do return scanner. Next line, after we do S out query. This is the easiest one, nice and easy. We print out what the requirement, what we're asking for, and we just grab the next line. It's just all of this is doing for us in the get string is allowing us to print something else first. Makes sense? Back to our liar's dice. We do need a console, that means. So let's go ahead and do, oh, that's replatted, by the way. That's my pad. Console. Console. New player. Console.getString. Player name. And we can really have some fun with this by doing player. I'll show that doesn't concatenate. We want to actually do that as a number. Count plus 1 plus name. See how that works? Player 1s, player 2s, player 3s. Good and good. So that should create each player and give them a cup. So we have X number of players, each with a cup. That's going to create our game. We're good, we're ready to go. We started it up. Players are there. We got that now. That's good. And now I'm looking at these. I want to readjust these a bit. This is not, I don't think this is the order we should build these methods. I'm going to move these over here for a second so we can really think about what we should build. What's the most overarching item? Or does anyone have one they think they should work on first, actually? Any method we think we should work on first? This is the tricky thing. This is why I wanted to touch base on this, because this can be difficult, deciding where to go first. And what I like to do, and what helps me a lot, is use what are called flow methods. Flow methods are the methods that just control the flow of the game or control the flow of the code. And those, out of these methods, can we think of any of these that might be like a flow method that controls the flow of the process? Did any of these kind of pop out at you as like controlling the flow? Any ideas? I'll just take a guess.
Check winner.
Check winner. Is that going to control the game? Decide what happens? I'm sure that seems to just do one thing, right? That does one thing.
Check dice.
Check dice. All right. How many things does that do? Does that do more than one thing, or does that just do one thing?
Oh, one thing.
Yeah, this can be, this is here to teach. So no, I'm really not expecting one to really definitely know. We look at these, we think about it. Validate claim does one thing. Is liar just checks one thing. Add player does one thing. But look at these two that have the word run in front of it. Run round and run turn. When I run the round, what do I have to do to run the round of liar's dice? What happens in a round of liar dice? Multiple things happen, right? And run around, I shake the cup, we put it down, we look at it, and then then the round says, okay, we'll now take turns making claims or calling lies, right? So run around is going to tell us to do multiple things. In order to perform a turn, now multiple things are going to happen too. On turn, we're going to look at our dice. We're going to decide whether or not the current claim is a lie or if I'm going to make my own claim. And then I actually do make my own claim. Once the turn's over, then the round also then says, well, once the turn system's over, once the turns are over and someone's called a lie, then we need to process the lie, and then we can actually go ahead and run the round again, run a new round. So these two are really kind of telling me that this is kind of controlling the game, right? And that's, just so you know, that's why I purposely made them call them run something. And I wanted to tell myself that these are not really doing anything other than telling the game what to do, controlling the game. And so these are things we're going to learn. And what I use these to kind of help me know what to build. I'm going to build it out in order. Because again, we're trying to use the real world to inspire our code. If I'm going to build a game, it's great for me to just kind of think, okay, well, what happens in the game? What's next? Well, let me build that next. What happens? Let me build that next. Instead of trying to jump around and build random things in random moments that might not make sense, might not fit in once I build everything out together. My way of doing it, again, you might change it again if this is not how your mind works. I'm going to bring these two first into the top. Run the round and run the turn. And that'll let me know out of these items here, which ones I should make in what order. I have no idea what to start with. I could check the winner, but that means I have to know, in order to check the winner, I have to know if everyone's out. Well, in order to know if a player's out, I need to be able to remove the player. Well, to remove the player, again, I still need to know, are they out? Well, in order to kick a player out, I need to know that they lied. Well, in order to know if they lied, I need to be able to validate, be able to check the claim and check the dice. So it's hard to know which direction I should go in these. So I'm going to just leave them like this, but I'm going to let the flow methods, these two, guide me on my path. They're going to tell me what methods to create in what order. Let's try that. Round. So the beginning of the round, what happens?
Player rolls or shakes the cup.
Yeah, they shake their cups, right? All players do. So let's do, we want all the players to shake their cups. How can I get all players to shake their cups? What am I using for that? What's that looping structure we used for the dice?
Say 4 in.
Right, 4 in, right? We want to make sure we want every player to roll them. We want to make sure every player does it. There's no player that gets to not roll their dice. So for var player and players, we're going to do player dot roll. Nice and easy, right? Now that while that looks easy and looks simple, I'm still, this is actually an action happening. This is actually something that's actually being done, and run round is just a flow controller. And so could I keep this here? Yes. But something else I can do that can be really nice in cleaning up your code is creating what are called utility methods that are just, they're private methods that are small methods that just run and make your code a little more legible. Here's an example of one. Private roll all. And all of this is not going to be the void. I'm going to just take this code, put it in here, and now this one's just going to simply say roll all cups. That's it. I don't need to know what this does in order to understand that's what's happening in the round. The round starts by rolling all cups, by rolling all the dice, by shaking all, oh, actually, no, let's do shake all cups. Shake all cups. Okay, I didn't call that shake actually, now that I think about it. We actually change it roll. Oh, you didn't make it roll. Okay, good. That's where it said shake, right? Shake all cups. That now makes more sense than roll all cups. I'm just picturing me rolling a cup down along the table. Not really great. So shake all cups. This, you might think this is getting a little repetitive, but since run around is going to do multiple actions, it's going to, we want to keep it nice and clean where it's just going to run one method, then run another method, then run another method. That kind of makes sense? It should really be doing no logic itself. It's going to call other items that are going to handle the logic for it. Run round is all it's doing is just deciding who's doing it. Think of run round almost like an operator or like the manager, or even maybe even better, the referee. They're just making sure everything's happening in the right order. They're just watching and say, okay, we'll do this, do that, do this, do that. Okay, you've got to put let's move things here, let's move things there. Run round isn't actually doing the game. Run round is making sure that the game runs smoothly. It's running each step in the process. And saying, okay, it's time to shake all cups. After we shake all cups, what's next?
Well, whoever's turn it is peaks.
Yeah, we'll then run the turns, right? In the beginning, we'll just say that player one always goes first every single round. we can make a more advanced system later that in the next round the other player goes, the second player, the third player, so we can always keep track of that later. But for the beginning, every round, let's say, you know what, it's gonna be evil. Every round, Christian makes the first call. Me and Christian played every single time we go, every new round, Christian always makes the first claim. It's not a good game to really think about it. That seems a little unfair. But again, we can always code that change later on, right? We can always add in the logic later that says, okay, first round, player 1 goes first. Second round, player 2 goes first. Third round, player 3 goes first, or player 1 goes first again. We'll do that cycle. We can always add that in later once we know that the rest of the stuff works. We shouldn't really get too deep and too worried about that kind of less important detail if the rest of the game doesn't even work yet. Why do we care who's going first each round if nothing else in the game works first, right? Does that make sense? Prioritize the pieces. Prioritize what items make more sense to do in order to get the game into a playable state. That's what you want to think about. What are the most important pieces that I need to get done now to make the game at least playable? Because I can always add in more items afterwards once I'm ready to add those. All right, so we're gonna run the turn. That means we're ready to run turns. We're ready to go through the turns now. How do we do the turns? Well, the turns are gonna go through player to player to player. And there's 2 types of turns. There's a first player turn and a second, and then there's every turn after that. First turn is special. First turn, you simply make a claim, right? The first turn is different from every turn after that. Every turn after that, it's decide the previous claim is a lie or make a new claim. So for now, let's not worry about looping yet. Let's not worry about making the turn yet, because this is not this first thing we're going to do is kind of a turn, but it's a special turn. So let's build it here. We'll probably pull it out later and pull it into one of these private methods later. So let's see what happens. So we rolled our cut, we rolled the dice. What is the first thing that we want to do for the player? This first, actually. Right now, we know it's always going to be player 1. Always going to be player 1 to start. But in that case, probably we actually should do this instead. Now that I think about it. Get 0. Are we not going to do a get name yet? I didn't, did I? Get name is not there, is it? This is where, again, this is where I tell you, like, don't worry about making those methods right away. We now know we need get name. We can see we didn't make it. Well, let's go add it now. Now that we know we need it, we don't ever make any unnecessary methods, right? We only have the methods we need. So we noticed, yep, we have names private. We never actually create a getter. So let's do that now. Yeah. Name. So show the name. So let's see again. Now for the next thing. So we display the name. It's their turn. What's the first thing that player's probably going to do? For the first, so we shook again. All we've done so far is we shake the cups. Jeremy, it's your turn. So you shook the cup. It's your turn. What's the first thing you're going to do?
Make a claim.
Just off the top of your head? Have you looked at your dice yet?
Oh, no.
Be a pretty impressive claim, I'll tell you that. I'm going to be like, I have no idea if this guy's lying. He hasn't even looked. Guy is going wild on me. We need to look at our dice, right? There we go.
Be a good claim.
It definitely would be a ballsy move. I would have no idea how to respond to that. I'm like, I think I should call them, but they have no idea. They don't even know if they're lying or not. So we'll do, what is it? I think our peak automatically displays. So let's just do players dot get 0 dot peak does void. Yep, so it's going to print it out automatically for us. And now I think it's ready. Now that you've looked at your dice, now what are you going to do?
Now I'm gonna make a claim.
Good. All right. So get 0 dot get claim. And as we know, the first claim is valid, right? The first claim, we're just going to take it as is. That is fine. There's almost no validation to it. So you know that the validator in the system is going to automatically check it. It's going to make sure that the dice value is 1 to 6, and they have to make up the claim between 1 and 14. So there's no way that they could make a bad claim, right? Well, I guess they could make a bad claim, but there's no way they could make an invalid claim, right? Whatever they say is fine. They could say there's 14 ones. I would say that's a bad claim, but it is a valid claim. So this is fine there. And that's their turn, right? That's the first turn. This is really all the first player does. The first player of the round looks at their dice, makes a claim, and that's the end of their turn, right? After that, now we get repetitive. Now we're going to go through each player one at a time, asking them whether and running their turn. Each player one at a time, right? Do we know when we're going to end the turn? We know how we're going to end it. We know we want to loop, right? We know we want to loop through each player and run their turn. We know there's going to be, we can assume there's going to be a way to break out of that loop, right? But does anyone know right now what our conditional is to break out of the loop? You can say no, by the way, that's a valid answer.
Is it just return?
No, I'm saying, do we know the conditional that would break the loop? Like we know we need to loop through our players and have them run their turn, right? But do we know what's going to end the turn cycle? We know the conditional that'll end our loop. Like just to throw it out there, we're going to do some sort of while something. Yeah, what is something? Run turns. So each player, run turns. We're just going to keep running the turns for each player one by one until something happens, until something tells us to stop. Does anyone know what this something is? Yet. Do you have to know what it is yet?
No.
Thank you. Yes, Jeremy. This is one of the tricky items where it's okay to say no, because we actually just saw a little while ago, thanks to Christian, there is a looping structure we can use that doesn't need a condition. Remember? We can break out once we know we can exit out. Remember that guy? Until we know what our conditional is, we'll use the while true trick in order to let us kind of write the code. And as we write the code, eventually we realize, oh, there it is. That's our condition. That's how we break out of the loop. And we might decide, you know what, keep it as break, or we can then move it into our item here, or even lastly, we might realize, oh, we can convert our while into a do while, or keep it as a while. We don't know yet. And that's one of the really useful things about this while true system is that we can use this to start our loop when we don't know what our condition is to end it. We know we need a loop. We know we're going to repeat. We don't know how long. We don't know until when. We have no clue right now. We know there's going to be a reason. We know that we're going to break out of this somehow. I don't know what the logic is yet. And I didn't when I first practiced this. So I started with a while true. So don't be afraid to be like, I don't know what it is yet. Well, I still can code even though I don't know. That's what's really powerful as you get into these things. Don't be afraid to admit, I don't know what this is yet, and I don't need to know it right away. I can use this to start continuing to write my code until I figure out what this is. Sound good? So don't be afraid to be like, I'm not sure what I need to write here. That's fine. While true. Let it constantly repeat until you figure out how to get out of it. So while true, we want to make sure each player in our list gets to play. I wonder if I'm going to be a little evil on using the list right away instead of just having 2 players, but it's fine. You're going to learn a little bit about how to use modulo. I don't know if anyone knew how to do this, but player 1's going to be the active player now. I'm going to do run turn. Get active player. And that's not going to work because we don't have a run turn yet. We do know this we want to do. We want to run the turn for the next player. So now we're going to build run turn. Before we do that, what I want to do next is I do want to write the code, though, the comments for what comes after the turns are over. So what ends our turn? When do we stop doing turns? What has to happen? Any idea? So Jeremy played, he made a claim. My turn now. I looked at my dice. Oh no, I said, no, I trust Jeremy. It's first turn. He said there's 1, 2. I'm pretty sure he has at least 1, 2 in his hand. So I look at my dice and like, all right, I'm gonna say there's 4 3s. Now if Jeremy looks at it, is there something Jeremy can do to end the round? End the turns. Where that
You're lying.
yeah, Jeremy can say that I'm lying, right? That ends the game, that ends the round because it ends the turns. Or not really ends the round, but ends the turns, we can finish the round. There we go. That's the right word I was looking for. When Jeremy or myself calls the claim as a lie, we end the turns and we go to finish the round. So lie called, and when we do that, we want to validate or confirm lie. Confirm claim. There we go. Confirm claim if confirmed if claim is a lie. Remove die from loser. Remove player if right. That's how the round will finish. And then determine if enough. Sound good? That makes sense. Because we know that there's players continue, we'll go back, we'll shake the cups then. If we call the lie, we know we know if the lie was a claim, if the claim was a lie or not. We remove a die from one of the players. We remove a player if they're out, and if there are still players to play, we're going to go ahead and go back to the top of the round, or we'll end the game. Sound good? Okay. 30. Oh, no. So run turn. We're going to kind of take the same things here. We're going to go ahead and do this item here again. We're going to change a bit to it. We're going to do player.getName. I was going to say player's turn. Press enter to continue. We want to make sure that player is at the keyboard before we show the actual dice. And so we're simply just going to do, oh, I need a scanner. Love the game. That's fine. Actually, I'm going to do a trick on this one. Instead of doing a system.out print line, I'm going to do console because I don't want to make a print scanner. Get string. We're not going to actually use the string. So this is just going to print this out. They're going to press enter. It's going to return the empty string, but we're not going to use it. So that's all this is going to do. This is going to allow us to pause the console until the person hits enter, saying, yep, I'm that player. You can show me my hand. Does that make sense? We don't want to show the hand unless we make, like, again, if me and Jeremy are playing on the same computer, Jeremy was player one. He did his thing. He made his claim. I don't want it to automatically show my hand until I tell Jeremy to go away from the screen. Like, Jeremy, move away. I'm going to hit enter once Jeremy's looking away. I'm going to play my round. Once I finish my round, again, I don't want to show the next thing until Jeremy hit. I don't want to see Jeremy's hand. Jeremy doesn't want me to see his hand, so he's going to hit enter when he's ready. There's going to be more that will be needed to be done to this to actually clear the previous stuff. I'm not going to get into that, but I just want to at least show this idea of hitting enter. Okay. Get string, player name, player name, press enter to continue. We're then going to go ahead and do, oh yeah, I'm going to get the decision on whether or not they're going to call the claim or not, right? Are they going to call the, are they going to claim lie or not? So, Boolean decision. Yeah, equals player dot get decision. Decision. And so in here, we're just going to do this for now. Mark this called lie and runs. So that would return at the moment. I don't return anything, we're just going to return, and that's going to come in later. I want to deal with that later. That's more complicated. I want to finish the rest of this because I know how the other stuff works. That's going to be similar to this. Ooh, I also got, dang it. Dot peak. There we go. Decision. I'm going to do this later because I know that if they don't make the claim, if they don't collide, they're just going to make a claim then, right? So then I can do this. Grab that, paste that. So far, so good. What I need to do next, though, is I got the claim, but in order to take that claim, I need to validate it now. So that's the next thing. Validate claim. Valid. Ask for new claim. Otherwise, we can move on with a new claim. So now here's where things get a little crazy, a little more dizzying. We may have to move some stuff around. Claim can't be returned. We're doing void. We also might want to return something different because a decision. So that's the thing we're going to do with Monday. So we weren't able to finish today. We got a little deeper into it. What I'm going to have you guys try over the weekend is this thing, how to validate the claim. So what I'm going to do first is we know that we're now using claim twice. So instead of making it a scope variable, let's make it a field. I'll cut that and bring that here as private and claim that and we're going to currently call this new claim for the moment, so you don't want to overwrite it yet, unless we know that, until we know that the new claim is valid, we can't overwrite this claim. We don't want to overwrite this claim until we know it's a valid claim. We set it. We get a new claim, and now we want to compare the new claim to the old claim to see if it's allowed. Remember the rules. New claim must increment either the value or the count of the previous claim. If the value is raised, count can be any number. If the count is raised, it must be higher than previous. Make sense? That's what you guys are going to try today. Public, Boolean, oh no, private. This is private. Boolean. Valid claim. that's what you're challenged to do today. See if you can come up with the code for this. That's what I want to see if we'll try to this weekend. That's your challenge for the weekend. Try to come up with the code that will validate the claim. Look at that. Jeremy's claim was there's 2 2s. If I try to say there's 1 2, I can't do that. I said there's less 2s than Jeremy said. If I say that there are 4 2s, that's a valid claim. I try to say there were more 2s. If I say there are 3 8, there are 3 4s, that's definitely valid because both numbers are incremented. If I say there is 1 4, that is valid because I incremented the value. I can say 1 4. Those are the ones you want to try. So that's your challenge to try over the weekend. Any questions? We're going to be reviewing what you come up with on Monday. We'll try to do class at 30, so hopefully everyone can get in. If you're unable to make it, please let me know. We want to make sure we're starting to do these more. We definitely, no matter what, this will be something I'm going to actually make an assignment in the classroom for. Yeah, let's do that. I want to see what you come up with. So, classroom. Assignment. Logic is a claim method requires twice. This own code. Provide GitHub link. Just clarify where it is. Just clarify the file, or download a repo. We'll grab that for everyone since it's here. I say download again because if you clone it, you won't be able to put it on your GitHub, I believe. Yeah. You can fork it. Now you could fork it and then clone it. But if you fork and push code to that, you will not get a green square. So that's why I recommend downloading it and making your own repo of what I've created. So downloading it will allow you to actually push to it and get credit for that. If you fork my repo though, and you push to that forked repo, you will not get a green square. So do be aware of those. That's the trick behind it. Okay. Sunday midnight. All right. Assign. All right, there we go. Make sure you work on this again. No matter what you create, whether you're not, it doesn't matter whether or not you're confident of it. The idea is you make an attempt on it. Try to come up with whatever you can. Write out some code. Try to come up with some sort of code to work on this. All right. All good. Any questions? All right. I will see everyone on Monday. Have a good weekend. Oh, wait, I have chats here. Oh, no. I need to remember that Christian sometimes can't talk and I look at the chat. Hey, Christian, if you're about to go silent, just let me know so I remember to open the chat window so I actually see it next time. Oh, he's already gone. I'll run one there. All right, everyone, see ya.